everyone, I'm Nikita and welcome to today's session on AWS Simple Queue Service or SQS. Whether you're a developer, an architect, or someone exploring AWS, understanding how message queuing works with SQS is critical. In this video, we'll cover the core functionalities of SQS, its importance, the different types of queues it offers, and some of the best practices to get the most out of it. So let's dive right into what SQS is and how it can help you build scalable and reliable applications. Amazon Simple Queue Service is a fully managed message queuing service provided by AWS. In simple terms, it allows different components of your applications to communicate with each other reliably and asynchronously. For example, if your application needs to process a high number of transactions, instead of overloading your system, SQS can queue these transactions, ensuring that they are processed one by one without missing a beat. So there are three key features of SQS, which includes firstly, reliability. Messages are delivered reliably and SQS ensures that no messages are lost. And second is scalability. SQS can automatically scale to handle millions of messages per second, whether you need to handle small tasks or process huge amounts of data. SQS has you covered all over. And finally, durability. Even if the service faces issues, messages remain safe and can be processed once the system recovers. Think about it like this: if you're running an e-commerce store on Black Friday, you need a system that can handle millions of orders and not miss a single one. That's where the reliability and scalability of SQS come into play. So why is SQS so important for building modern cloud-based applications? Let's see it. Firstly, for its asynchronous communication. SQS allows components to communicate without waiting for each other. By this, it improves your system's efficiency by allowing different parts of your applications to work independently. And secondly, for its decoupling components. With SQS, different parts of your application don't need to rely on each other. And this reduces complexity and makes your system more flexible. And lastly, for its improved performance. Offloading tasks to SQS reduces the load on your main applications, allowing it to focus on the important tasks while SQS just handles the rest of it. So let's face it, no one likes waiting, right? In a world of instant gratification, asynchronous communication is a game changer. By using SQS, you make sure your users aren't left waiting, even if the things are happening behind the scenes. Now, AWS SQS offers two types of queues: standard queues and first in, first out queues. So let's break down what each one does. First is standard queues. They are perfect if you need high throughput and low latency. These queues offer best effort delivery, which means messages are processed as quickly as possible, but the order might not always be guaranteed. And second is first in, first out queues, which ensures that messages are processed in the exact order they are sent. This is critical when the order matters, like processing financial transactions or stock market orders. However, first in, first out queues are slightly more expensive. Here is a quick analogy. Standard queues are like sending out messages in a group chat. They are just get there fast, but the order isn't always guaranteed. On the other hand, first in, first out queues are like mailing checks. Like, you want to make sure the first check sent is the first one processed. SQS doesn't operate in isolation because it integrates seamlessly with other AWS resources to unlock powerful use cases such as SQS with AWS Lambda. You can trigger Lambda functions based on incoming SQS messages, enabling serverless architectures. Imagine processing incoming orders or logs automatically based on queue events. And then SQS with SNS. SQS can be used as a target for SNS notifications, allowing you to process messages from multiple publishers. And finally, SQS with DynamoDB. Process data changes from DynamoDB streams by triggering actions in SQS, creating a real time processing pipeline. Setting up SQS is real simple and can be done via AWS console, command line, or SDKs. Here is a quick overview of the process. Firstly, create an SQS queue. Head to the SQS console and choose whether you want a standard or first in, first out queue based on your needs. Set parameters like the message retention period, which is for how long messages are stored, and then visibility timeout, for which how long a message is hidden from others while being processed, and then dead letter queues, which is for where failed messages are sent. And then once your queue is set up, you can start sending messages to it and then retrieving them for processing using the AWS SDK or command line. So let's go create a queue. I'll navigate to SQS in the console, SQS, and then I'll say create queue. As we start off here, you'll see that you choose the queue type either standard or FIFO, like we talked about, and also the message that you can't change the queue type after it's created. So choose carefully most of the time. So standard is going to be what we use, and that's what we are going to take up. Name, I'm going to keep it as demo SQS, or let's keep demo Q. And then here in configuration, the visibility timeout is 30 seconds, delivery delay is 0, receive message is for wait time while receiving the message, and let's keep it as 0 only. Message retention period is 4 days, and maximum message size is 256. Let's keep all of this as default. Let's not make any changes here. But in the visibility timeout, uh, if it is 30 seconds, the message in that 30 seconds, the message hadn't been processed. The consumer number two would be able to see it and pick it up and process it. And that's what can lead to duplicate processing. So make sure how much seconds you want for this visibility timeout. If you want, you can increase or you can decrease. And then encryption, let's keep the server side encryption enabled and the key encryption type as SQSQ only. And in access policy, well, let's keep all of this default as well. Scroll down here, dead letter Q we talked about in the slides, and the allow policy as well. So let's go and say create queue. Now let's go and click on send and receive messages. I'll say here, here is the first welcome message. And let's keep all of this same. The delivery delay. This is for the receive messages. We are talking only about send messages here. So our first message would be this. I'll click on send message. And next we have to do the second message. So I'll say here is the final welcome message. And then I'll click on send message. So messages have been sent. They are ready to be received, which we can do down here. And you have two messages available to be received by your consumers. Now, in real world scenario, your applications would programmatically be pulling these queues, checking for new messages, but we can simulate that by clicking on this button called poll for messages. Let me just click on it, and you can see that it is being processed our two messages. Let's just wait for a few seconds. So yes, now both of the messages are received, and if I click into the top one here, I'll get the message. Here is the first welcome message which we wrote in the first time. And then if I click on the second message, you can see here is the final welcome message. So yeah, that's how you do. Now I'll just manually delete the message. I'll say delete, and you can see two messages are deleted successfully. I'll go back to the demo queue. I'll go to the queues and I'll select the queue which I created just before. I'll select it and I'll say delete. And I'll say confirm here. Okay, delete. So yeah, you that's how you create a simple queue. I hope this was easy way to be created. Now that you know how to set up SQS, here are some of the best practices to ensure you get the most out of it. First is use first in first out queues for strict order. If the sequence of messages is critical, first in first out queues are the way to go. And second is to monitor queue metrics for performance. For this, use Amazon CloudWatch to monitor your queues performance, such as message processing time and error rates. And third is configure dead letter queues for failed messages. Avoid losing failed messages. Always configure a dead letter queue. And then retry mechanism. This is implement retry mechanisms to handle any message processing failures gracefully. And then optimize message size. Messages can be batched to reduce the number of requests, saving costs and improving performance. And lastly, encryption. For sensitive data, consider encrypting your messages using AWS Key Management Service, which is KMS. These best practices aren't just recommendations because they are essential for maintaining an efficient and secure system. Following them ensures your system runs smoothly even under high loads. And to sum it up, AWS SQS is an incredibly versatile and scalable messaging service that simplifies asynchronous communication between application components. With features like scalability, durability, and seamless integration with other AWS services, SQS enables you to build highly reliable and efficient systems. And by following best practices and selecting the right type of queue, whether it's a standard queue for high throughput or a first in, first out queue for strict message order, you can just ensure that your applications perform at their best. So, yes, this was all about SQS. Thank you for joining me today. I hope this video gave you a clear understanding of AWS SQS and how you can use it to build scalable, high performing applications. So, yeah, until next time, stay innovative, keep building, and leverage the power of AWS to create amazing solutions.